We start the new chapter, straight lines. Now, for example, we can very well imagine what a straight line is. Straight line is something of this sort. This is straight lines. These are what? Straight lines. Now, for making or for drawing a straight line, we need a minimum of 2 points. That is, if we have 2 points, let's say we have this point and this point. Now, by joining these 2 points, we can get a straight line. We can definitely get a straight line through these 2 points. If we have only one point, then how many straight lines can we draw through it? There will be infinite straight lines that can be drawn through it. These are infinite lines that can be drawn through this point. But if we fix another point, let's say we fix another point apart from this point, let's say this is point A and this is point B. Now, how many lines can be drawn through these 2 points? And the answer would be just one line. There is only one line that can be drawn through these 2 points. Therefore, for drawing a unique straight line, we need a minimum of 2 points. If we know 2 points, we can draw a straight line, and through 2 points, only one line can pass through. The first point. The second point. Now, in this chapter, we will combine coordinate geometry with straight lines. The coordinate geometry that you studied in class 10 will now be combined with the straight lines. Now, for example, this is our rectangular coordinate system. This becomes your y-axis. This becomes your x-axis. Now, in how many ways can we draw straight lines on this plane? The lines could be of how many types? First of all, let's say we have lines which are like this. Could be below x-axis, could be above x-axis. The second type of lines could be this is y, this is x. The lines could be parallel to y-axis, rather could be parallel to y-axis like this, or let's say third type, the lines could be like this, the lines could be like this. This is y-axis, this is x-axis. So if we look closely, the lines of this kind are called horizontal lines. These are called horizontal lines. Why? Because they are parallel to x-axis. Similarly, these lines are called vertical lines. Why? Because they are parallel to y-axis. And these are called oblique lines. These are called oblique lines, or rather slant or oblique. So the lines can be classified as vertical lines, horizontal line, and oblique lines. Next, the next point that we should remember is there are certain terminology that are associated with straight lines. We will talk of certain terminologies. The first word that we should be aware of is the word inclination. What does inclination mean? Inclination is first of all represented by theta. Its definition is, it is the angle made by the line with the positive direction of x-axis measured anti-clockwise. Now, what do we mean by this definition? For example, we have a straight line like this, or a straight line like this, or a straight line like this, or a straight line like this. Now, what does the definition say? Inclination is the angle which is made by the line with the positive direction of x-axis measured anti-clockwise. Now, what do we mean by anti-clockwise? Anti-clockwise is when we move in the opposite direction to which the clock moves. The clock moves in this direction. Therefore, anti-clockwise means we are moving in this direction. This is clockwise. This is anti-clockwise. ACW is anti-clockwise. Now, this is your x-axis. This is your y-axis. This is your x-axis. This is your y-axis. This is your x-axis. This is your y-axis. This is your x-axis, and this is your y-axis. Now, what is angle theta? Angle theta is the angle made by the line with the positive direction of x-axis. Now, which is the positive direction of x-axis? This direction is the positive direction. 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 The angle made by this line with the positive direction of the x-axis measured anti-clockwise. Now, this is the angle we are looking for and measured anti-clockwise. This is theta. Similarly, positive direction and the angle made by the line with the positive direction of x-axis measured anti-clockwise. This is theta. This would be theta. Positive direction and anti-clockwise. Positive direction and anti-clockwise. You could say that the angle could be this. We will not consider this angle when we talk of inclination. Inclination will always be the angle which the line makes with the positive direction and anti-clockwise. That is, for example, if we have this, so we won't take this angle. We won't take this angle. Why? Because this angle is being made with the negative direction of the x-axis. Negative direction of the x-axis. We have to consider the angle which the line makes with the positive direction of the x-axis, and we have to measure it anti-clockwise. This is not the angle. We will take this as angle. Now, if our line is horizontal, let's say our line is horizontal. Let's say we have our line is like this, or our line is like this, that is parallel to y-axis. These were the other two cases. Now, the angle made by this line, this is x-axis, this is y-axis. This is x-axis, this is y-axis. Now, the angle made by the line which is parallel to y-axis will be what? This would be 90 degree, because this angle is 90 degree. If these two lines are parallel, therefore this angle has to be 90 degree. Therefore, if the line is parallel to x-axis, or rather parallel to y-axis, then angle of inclination, that is represented by theta, is what? 90 degree. And if the line is parallel to x-axis, then angle made between these two lines would be 0 degree. These 2 points you have to remember. If the line is parallel to y-axis, then angle of inclination is 90. If the line is parallel to x-axis, then angle of inclination is 0. And in all the other cases, we will have to find out the angle, but we will take which angle? The angle which the line makes with the positive direction of x-axis and measured anti-clockwise.